Well, good day once again. So in this series of video tutorials, I will be taking us through the solar system design processes. Like we all know, every design consists of different processes. Now, there are 6 common stages that is involved in the design of any solar system, whether off-grid or on-grid. Off-grid is the one that is not connected to the power supply, while the on-grid is the one that is connected to the grid. So the first stage, or let me say the very basis, before you go to the market and begins to buy this, buy that, buy battery, buy solar panel, buy inverter system and other stuffs, is number one, you do what we call load analysis. Load analysis is just simple: meeting the clients, getting the load demands and the hours of usage of those loads. It's as simple as that. That's the simplest way of explaining this. And for this video, I'm going to be using a typical load system for a client that I've worked with. Now, there is a small facilities that we recently worked upon. Number one, in the facilities, by inspection, we found out that they need an LED light with a power rating of 20 watt, and that 20 watts will be on for at least 8 hours a day. It is a DC. LED light is a DC, and remember, our solar system have a DC output as well. That's both AC and DC output, so you can easily connect this LED light. You don't even need to go through the inverter to power the LED light. So that's a LED light, 20 watt for 8 hours. So that will give us 20 hours multiplied by 8 hours. That will give us 160 watts hours. That is when you multiply it, that is 20 multiplied by 8. And we have a fridge with the power of 1000 watts, and a 100 watts fridge, and that need to be on for 8 hours as well. So 100 multiplied by 8, that is 800 watt hours. So 800 watt hours. Then we have a laptop that need to be charged. Laptop with a power of let's say 35 watt, and it takes approximately 4 hours to charge a laptop. 4 hours. It's 1400. That's a 35 multiplied by 4. That would be 140 watt hours. That would be 140 watt hours. Then we have a television, TV, with a 50 watt. TV equals to 50 watts. 50 watt television that will be on for just 1 hour. For 1 hour. So that means 50 multiplied by 1 is a 50 watt hours. Then we shouldn't forget that there are mistakes that many designers used to make when you are designing an inverter system, is by not taking cognizance of the fact that the inverter system itself is a load. It's a load to the solar panel, it's a load to the battery. So the inverter itself is 20 watt. The inverter itself is 20 watt. And remember, the inverter will be on throughout the day. So that's multiplied by 24 for 24 hours. So that will give us 480 watt hours. So from here now, you can simply calculate total watt hour will be equal to the summation of all this. So Let's try to sum everything together. So that is 480 plus 50 plus 140 plus 800 plus 160 as a 1630 watt hour. So the total power demand for that system is 1630 watt hour. That is just, so your own load might be different, but that is just how we estimate the load. Now if you have a gadget and maybe peradventure you don't know the power, you can easily go online, give you the typical power rating. So that is that about load estimation. So when you have done this, it is the value, the final values you got from this, that will now determine the next stage or the next phase of the system. So that will be all for now in this very short videos. So in the next video, we'll take you through how to get the battery voltage selection, calculating for the size of the inverter, and finding your sun region, and so on and so forth, as the case may be. Thank you very much. Please do subscribe to my YouTube channel, like my Facebook page to get more up-to-date information and videos regarding the field of electrical and electronics engineering. Thank you.